now I have to say. Didn't I tell you yesterday what you got? 95. It's a hot seat for you, Tommy. Okay, I'll give you your grades at the end. So, more word problems, more reading. Read slowly. Okay. A surveyor is mapping a triangular plot of land. Did you guys pass your homeworks forward? Oh, there they are. So he measures two of the sides and the angle formed by these two sides and finds that the lengths are, so I'm just going to draw any random triangular plot of land. He measures two of the sides and the angle formed by these two sides, so that would be the angle in between them, and finds that the lengths are 400 yards, 200 yards, and the included angle is 50 degrees. What is the measure of the third side? So what's going to help us find this? Which law of cosines, right? So this is what we're looking for, the third side. And so set that up for me, Maya. If you had to guess what she's setting up, what would you think? Okay, so Ellie says, wouldn't it be x over the sine of 50? Yes, if you're making the same assumption. Right. She's using the law of sines, I think. And if she was supposed to be using the law of sines, yes, Allie, it would be x over the sine of 50. We can't do the law of sines, though, because we don't have an opposite angle, opposite side pair that's completed. Correct, not a right triangle. And that's going to have to be on the test something you have to differentiate. Is this a right triangle? Great, I can use SOHCAHTOA. If it's not, you can't. Can you try again? Law of cosines. Good. Some of you on your quizzes put like the sine of 50. Like you did the law of cosines, but you used sine of 50 at the end. So that threw you off. But this is just type it into your calculator. So this is fairly straightforward. I recommend you do it all at the same time. So 400 squared plus 200 squared minus 2 times 400 times 200 times cosine 50. That'll give you your x squared number. Well, I guess I can tell you that. They're like, all of these programming calculators. If he needs to find this inside of any time, he just types in A equals B equals. Right, I know. Well, that's why we cleared calculators, right? Clearing calculators would get rid of all of that. Oh, he didn't do it. His tutor did it for him. His SAT tutor did it for him. That's what I said. But apparently... Right. So 312, once you take the square root of both sides. I don't know if he can do it for, like, he doesn't know how to do it. His tutor did it for him. Good luck. All right. there's only certain things he can do it with, like side angle side. I'd have to go back and look at his test, but because on his test there's no work at all. Right here. No, because it's impossible unless you're cheating, looking at the person next to you, or using a program on your calculator.
That's cheating? That's the only way it has something. That's using your resources.
Okay, if you can figure it out, go for it.
I'll figure it out.
Okay. What is... Yeah, whatever. All right. Area. What's the area? Here's another thing you did on your quizzes. A lot of people use the area formula when the question didn't even mention area. Wasn't even talking about area. Well, there was an area problem on there, but the question had the word area in there. I'm pretty sure. Right. But people were using it when it didn't even say anything about area. There were a couple people, and it was a couple random. It wasn't like a general trend or anything, but there were cases. And when I do read that, I'm like, why are they using area? It has to mention something about the area. But the area formula is 1/2 AB sine C. You guys were all very good with your formulas. And so that would be what? Good. Maggie, what would you plug in? Tommy, put that away. You're not doing that now. Good. So just type that in and nearest square yards, 30,641.42. This is 41.7 yards squared. So all of that is identical to what we've been doing. It's just that there's two different tiers of questions within the same problem. No, we didn't even use one to find the other. This one might be a little different. So why don't we do this? Everybody try to draw your own picture first, because I think more than anything, that's what we struggle with. Yeah, it tends to be just reading and drawing a picture according to a description is definitely challenging. Let me see, from 2 points on a level ground in line with the foot of a tree and on the same side of the tree. So I think there's one tree. There's my tree. So from 2 points on level ground, so this will be my level ground, in line with the foot of a tree and on the same side of the tree. So both points, and I'll call one point A and one point B. So there's 2 points, but one tree. The angle of elevations of the top of the tree are 41 and 47. So which one is the smaller one? This is important. We kind of did this one yesterday with the shadow problem. A is smaller. The further out you draw this, the smaller the angle. So this one would have to be labeled 41 and this one 47. The distance between the 2 points is 50. Find to the nearest foot the height of the tree, which is over here, X. Okay. So if you just worked on, how many right triangles do you have? 2 right triangles. So if you just looked at this right triangle, you would need another side in order to be able to do it, right? You've got the angle. You are looking for the opposite side. You would need the hypotenuse or the adjacent. If you were doing this bigger right triangle, so ignore that piece down the middle, you've got an angle. You're looking for the opposite side again, but you don't have the hypotenuse, and you also don't have the adjacent. Do you follow? You have a part of the adjacent, but you don't have the full adjacent. So unfortunately, we can't capitalize on those right triangles right from the start, but we can. The other triangle that we do have is this one, and it happens to be the triangle that we know the most about. It's not right, So we can't use SOHCAHTOA and be done with it. We have to use either law of sines, law of cosines. So first of all, this angle is not technically a part of this triangle, but it will give us this one. What's that? Angle. What? 133, because these two angles form a straight line, and straight lines are 180 degrees. So we really don't so much as need that right now. I'll leave it there, but we don't need it in the moment. So if you are using this triangle here, what should we be finding about this triangle that will eventually be used to help us find that? Why the top angle? Wait, let's go back to Connor. So if I find that angle, which that's pretty easy, Connor. I'll just do 180 minus this minus that.
Yeah.
Then what am I going to do with that?
And you're going to add 41 plus that other top angle of 90 small angle.
Oh, to get this one.
Yeah, you do that.
Okay, but so what? I already can do that, Connor. 47 and 90. So I already can do that. So tell me, if I label this A, B, C, and D, find what leg, Brock? A, D, this one. Okay, so if I find this one, then I can use the big right triangle, right? And I'll be looking for the opposite, and I will eventually know the hypotenuse, yes? Or if I find this length, I could do that too. And if I find this length, then I can just use the smaller of the two right triangles and do opposite over hypotenuse and the smaller. So you have a choice, and we do it two different ways. Do you follow that? Just for the sake of going with the first one that was said, let's find AD. So if we're looking for AD, so we're focusing, and I'm just going to cover up the other triangle, we're focusing on that triangle. How are we going to find it? Law of sines. I can't actually use the law of cosines because I'd have x squared by itself equals something squared plus something else squared that I don't know. So I'd have too many unknowns. Do you follow that, Brock? So I can do law of sines because I have an opposite angle, opposite side that I'm looking for, and I can easily, like Connor did suggest, we could use that angle because we have its opposite side. So really quickly, 41 and 133 makes 174. So how big is this angle? 6. So now my law of sines will be 50 over the sine of 6 equals x over the sine of 133. I'm going to not call that x anymore. So cross multiply 50 times the sine of 133 will equal x times the sine of 6. And we just divide both sides by sine of 6. So divide by the sine of 6. And I'm going to get x equals 349. I'm going to round it on paper to the 0.8, but if I go and then use it, I'm going to use the exact decimal that's on my screen. So 349.8, I'm just cutting it off for the sake of writing. But you never use a rounded answer to make a follow-up calculation. So when I go to use that, I'm not going to use that. I'm going to use the full decimal for my calculator. So now we can focus on this triangle. And I can kind of block that from my mind, because I'm looking for the opposite, which I'll call y. Can't call it x again because I already used x. So the opposite is y over the hypotenuse. So I'm using what? Opposite over hypotenuse. Sine. So the sine of 41 equals y over 349.8. Not really, but that's what I'm writing. Multiply both sides by 349.8, or really the decimal that's on my calculator. So the sine of 41 times, scroll up, grab that answer, So you're not using a rounded answer. And you get 229.5. So the nearest foot is what? 230. Yeah, I outlined that in the two ways. Yeah. Did you do it a different way? Right, and you got the same thing. Good. Yeah. So that is going to make a difference. So did you use 349.8? And you're not supposed to use a rounded answer. So sometimes when you use a rounded answer, it actually doesn't affect you. You kind of get lucky. But you don't know when and if that's going to happen. So you don't use a rounded answer to make a follow-up calculation. You have to use the exact answer. Good? I'm going to give you, right, not your homework, but your, well, I'm going to show you that problem from yesterday. So 2, 5, 4, and 7. I'm just totally making those up. And we were asked to find x in between. And a lot of you immediately went to the geometry thought process that there was a diagram like this that you did, but you would have to know that this is congruent to that. That it was an angle bisector. And if it's an angle bisector, that just tells you that 2 over 5 equals 4 over 7, which isn't true. So we know that that angle actually is not being cut perfectly in half, right? So 2 of you got this. So this, if you had to find x, you would have to, I didn't give you any angle measures, did I? Okay, so you would have to momentarily block out that x from your head. So this would be 2, this would be 12, and this would be 4, right? And then I can find any one of these 3 angles. I don't want to find the top angle because even if I find the whole top angle, I don't know how it's going to be split up. So if you find one of these corner angles, and I'll find that one, what formula? Law of cosine. So, Alyssa, set up the law of cosines for me if we're finding x. Good. So we would solve for x, so I'll do that quickly. 2 squared. I still had people on the quiz, by the way, combining all of this into one big number, which is not okay. Subtract over the 4 squared. Subtract over the 12 squared. Which gives negative 156, and this whole thing is negative 96. Divide both sides by negative 96. Oh, man. Trivia question for bonus points. No. I gave you bonus points for that yesterday. Yes. So when I do inverse cosine right now, I'm going to get an undefined. Not because I did anything wrong. Because I made up numbers that are impossible. Why are these numbers not possible for a triangle? Raise your hand if you know. And first come, first serve for bonus points. Andrew? What's that? Mike? Correct. So with 2 sides of a triangle, your third side has to be somewhere between the sum of those, which is 6, and the difference of those, which is 2. So my third side had to be between 2 and 6. So no, Mike gets the point. So I'm just going to change it quickly to 1 and 3. Oh, I don't really like 1 and 3 though either. Okay.
All I know is me and Andrew got it right.
So let's just pretend for a minute that didn't happen, and now we know this angle measure. Let's pretend it's 35 degrees. Now that you know that angle measure is 35 degrees from the whole triangle, now you can just cover it up and do law of cosines one more time just in that triangle, which is what Tommy and Andrew did and got it right. So this law of cosines twice. But it's the same idea as that last one on our notes. Like, you have to be able to visually block and realize that there's 3 triangles in this picture. There are 3 triangles in this picture. And we use 2 of the 3 of them. And kind of have to block this out of your head at first to find that, and then block this side out of your head to just find x. Good? We get the concept. Oh, that is how I used to. I think so. Here, I just finished recording.